Okay, light and ultraviolet radiation. Okay, these are things you need to know about light and ultraviolet radiation. You need to be able to describe the uses and dangers associated with UV radiation. Okay, UV radiation, if you go out in the sun, then you are being exposed to UV radiation from the sun, being produced from the sun. And we all know what that does. If you stay out in the sun too long, you get sunburn. Okay, so it damages the cells in your skin because they're receiving too much energy from the UV radiation. So that is one danger associated with UV radiation. Another use of UV radiation is, for example, you should have seen one of these. It's a security marker. Okay, and this is a UV light. Okay, so these two things can come in useful if you want to mark your material, but it not show up unless a robber takes it along and a policeman comes along and tries to find out whose material it belongs to. Okay, so I need some sort of object here. Maybe if I get a bit of paper, hang on. Here's a bit of paper, okay. So this is going to be my prized possession, which I don't want, which I want back if the policeman catches the robber. I want this back here, and if I write here and say this is Mr. Collins's paper, and he wants it back. I've used the security marker, and you should be able to see. We should not be able to see on there the security marker. Okay, but if you get the UV light and you shine the UV light on there, what happens, what hopefully happens, is the message should become clear. So there you go, you can't see it at the moment. Here comes the UV light, and you can say, Mr. Collins, it's his paper, okay, he wants it back. By the way, can you see UV light? No, you cannot see UV light. You can only see visible light, okay? This looks a bit violet, that's because it's also emitting visible parts of the spectrum. But the UV light that's producing, you cannot see. However, when that UV light gets absorbed by the security marker ink, okay, the frequency is shifted towards the lower end of the spectrum. The frequency becomes less because it's losing energy. Remember, this side, the right-hand side of the spectrum, is lower energy. So when a wave loses energy, its frequency decreases. So it goes from being ultraviolet, a higher frequency than visible light, and being invisible, to being a lower frequency that is visible. Okay? So the light gets absorbed. I'll show you a diagram for this. Here. On the smartboard, I'll get a pen out like this. So imagine this can be my security pen. So that can be that's the ink there, okay, and this is the paper. So I've drawn it bigger than to scale. Here comes the invisible UV radiation. Okay, it gets absorbed by the ink, and then loses energy. So the frequency increases. So the frequency decreases because it's lost energy. The wavelength increases, and this is visible. So it emits visible. So this is the UV. UV goes in, loses energy, emits visible. Okay, so that's how the security pen works. Then, what do we need to talk about? We need to talk about the next thing. You need to be able to draw diagrams illustrating the concept of reflection, transmission, and absorption. So you just basically need to know what those key words are. So reflection is basically when a wave comes and bounces off. That's reflection. Okay. Transmission is when the wave goes in one end and is sent out the other end, transmitted, it passes through the matter. And absorption is when some of that energy is taken in, some of the wave is absorbed and taken in, like a sponge, like taking away some of the energy, like soaking up some of the energy like a sponge soaks up water. Okay, so reflection, bounce off, transmission when it goes through, absorption when some of the energy is taken away, some of the wave disappears into the medium, into the whatever it is. Explain what happens in reflection, transmission and absorption in terms of energy. So again, when something is reflected, there should really be no loss of energy. The reflected light should be of the same frequency. When it's transmitted, okay, then it goes in one side, might lose some energy on the way through, and then be emitted as a lower frequency, so the energy will decrease. And absorption, again, the energy is